Hello kids, welcome to PW English. This is me Arvind Suthar, your mathematics expert, to take you guys ahead in your class 11th preparation for IIT JEE. So let me introduce myself quickly so that we can take today's agenda. My name is Arvind Suthar. I am a graduate of IIT Roorkee. For the last 7 years, I have been teaching JEE aspirants and I have been associated with multiple online education platforms so far, but now I am associated with PW, which all of you guys know is working day in and day out so that we guys can make quality education accessible, affordable and available to all of you guys. So here we go into the session of basic mathematics, and in this session we're gonna cover a lot of things. Number one, we're gonna have a look at basic identities. There are no acidic identities in mathematics, there are only basic ones. Okay, and then we're gonna have a look at inequalities and wavy curve method. I hope you are all aware of inequalities. If any student is there who haven't learnt identities and inequalities up to the JEE level, then also he or she can attend this session. And even if you have started your JEE preparation and you are not comfortable with concepts, so in this victory batch, each and everything is going to get covered. So in this basic identities portion, we're gonna have a look at a plus b ka whole square, which I think all of you guys know, yes or no? Now these identities are relatively simple, but a lot of students don't know how to apply them in problem solving. Are you amazed? I'll tell you. A minus b ka whole square is also there. Then few identities like a cube plus b cube plus c cube minus 3abc. And there are identities like a plus b plus c whole square. And there are identities like a square plus b square plus c square minus ab minus bc minus ca. So we're going to have a look at all those important identities, number one. Number two, then we will be dealing with inequalities. Inequalities do have these kind of symbols. I hope you guys are all aware. By using these inequalities, we have derived a method, wavy curve method, which is used to solve inequalities in a fairly easy way. But a lot of students don't know why do we apply this wavy curve method or what is the origin of that. So in this session, we're going to cover both of these things. We're going to take relatively simple problems of inequalities. Sir, what about the complex problems, or what about the problems which are going to be tough in nature? Where are we going to deal them? And sir, what about greatest integer function? What about fractional part function? What about modulus function? What about rational inequalities? What about irrational inequalities? We're going to cover each and everything, but in the upcoming sessions. The next session for you guys is going to be of relations and functions. So I would like to take logarithms there only. I would like to take inequalities involving modulus function itself, and also greatest integer functions there in relations and functions only, so that we cover entire logarithm in just one go. I would have taken logarithm here as well, but I don't want that we cover things in parts, because that you have already covered, right? So what we're gonna do is we're gonna have a look at these two very simple things, because this is our first session of the victory batch. I want to make this video a bit short for all of you guys so that you guys are all geared up for the upcoming sessions. And it's very important to learn each and everything that I'm going to share here in this session for all of you guys, because a lot of guys think I can't solve problems, even though I know each and every concept. But the problem lies here. If you are not able to solve problems, then the problem is where? The problem is that you are not able to cope up with the concepts pretty well. So this is a conceptual express which I'm bringing to you guys, so that we can definitely nail each and every question that will be coming in front of you. Whether it is a JEE main question, whether it is a JEE advanced question, or whatever competitive examination question it is. So without wasting any time, I am taking you ahead into the world of basic mathematics. Here we go, bacha party. Basic mathematics. And that too, number one portion under this. What's that? Basic identities. Identities is what? Identities is something which is always true. Identities is something which is always true. Let's say I write this particular thing, a plus b to the whole power 2. Now this is equal to what? Everyone knows what it is? A square plus 2ab plus b square. Yes, everyone? Okay. What is a minus b to the whole power 2? That is nothing but equal to a square minus 2ab plus b square. Yes or no? Each and every one of you knows these two very basic things. Yes? Isn't it easy? Very easy. Now with the help of these two things, what we gonna do? That with the help of these two things, we gonna solve some complex looking equations like this. Equations like this. You can solve equations like this with the help of these two identities, and that too in a very, very, very easier way. Now JEE asks a lot of questions based on this, but this is not that difficult. A lot of guys, by just looking at the equation, feels this is a bit tough, sir. No, it is very easy. With the help of these two identities only, we will learn how to solve these equations. So that is going to be our agenda number 1 under basic identities. So before I go into the session, I would like to quickly give you one recent year JEE ka problem. Don't you want that? Don't you want to solve first problem, and that too of the recent year JEE main problem? Yes? Okay, let me give you that particular question. Example, if P plus Q is equal to 2 and P to the power 4 plus Q to the power 4 is equal to 272, then what is the value of P into Q? Then the value of P times Q is what? This is a JEE main 2021 question, kids. JEE main 2021 question. Can you solve this? How many of you guys feel that you guys can solve this problem? I want to see each and everyone out there. Just pause the video and try to solve this question on your own. P plus Q equals to 2 given to us. P to the power 4 plus Q to the power 4 is given to us 272, and then P times Q is what the question needing from us. I said okay. If P plus Q is equal to 2 given to me, and if I square both sides, will I be getting P to the power 2 and Q to the power 2 terms from this equation? Also, I'll be getting 2 times of P into Q as well. And P into Q is what? P times Q is what? I need to find out. So I said, okay, let's square this equation first. The moment I square it, what do I get? I get P to the power 2 plus Q to the power 2 plus 2 into P times Q, that is equal to 4. I said, okay, but sir, this thing is what I want, P times Q, but P to the power 2 plus Q to the power 2 I'm not having. I said, yes, you are not having that, but can you use it somehow so that, can you use this equation somehow so that you can solve for P times Q? Yes, I think you can. Let's see how we can do this. We can write down this P square plus Q square is equal to 4 minus 2 times of P into Q. Okay, squaring again both sides. Squaring again both sides. Will you be getting P to the power 4 and Q to the power 4 terms? And don't you think that you need such kind of terms because this thing was already given to you? Yes, let's try to solve this a bit, guys. So we can get P to the power 4 plus Q to the power 4 plus 2 times of P square times Q square is equal to. On the right hand side also, we can apply A minus B to the whole power 2. Yes, so it will become 4 ka square, that is 16, plus 4P square Q square, the square of this particular thing, minus 2 into 4 into 2pq. Yes or no? That is 16 times p into q you're gonna get. Everyone, are we guys comfortable till here? Anyone is having any difficulty? Do let me know. No difficulty? Everyone? Yes? Alright. Now, let's have a look at this beautiful thing over here. So this value was given to us. How much is it? Sir, it is 272 given to us. I said, okay, put it. Now, all the terms that you are having, this one, this one, this one, all of them are having p times q in it. Yes? Can you solve for p times q from here? I think it is going to be very, very, very easy for you guys. So this is one such question where JEE people wanted you to solve this kind of problem as well, and I think it's a relatively very, very, very easy problem based on the concepts of very junior classes, not even of, you can say IIT level, not even of IIT level. Yes or no? But this question was asked in JEE Main, and that too in a recent year itself. Chalo ji. So let's solve this problem a bit. We can write down this particular equation as 272. Let's combine the constant terms together, minus 16. If we bring the 16 onto the left hand side, and then this will become 2p square. If we bring on the right hand side, so 4p square q square minus 2p square q square will become 2p square q square minus 16p times q. Yes or no, everyone? Can you solve this particular equation now? 272 minus 16 will become what? It will become 256 is equal to 2p square q square minus 16p times q. Okay, can we cut 2 on both the sides, or can we take this 2 common and send it below this 256? Okay, the moment we're gonna do that, it will become 128, and this will become p into q ka whole square, and this will become 8 times of p into q. Yes or no? Can you solve this particular equation to get the value of p times q, everyone? Try to solve it and tell me the answer, because JEE Wallahs want you to solve this very, very, very easy problem, kids. So what I'm having with me is 128 is equal to p times q ka whole square minus 8 times p into q. The moment I assume p times q as t, it will become a quadratic in t, isn't it? T square minus 8t, bringing this 128 onto the right hand side. This is what I'm gonna get, everyone. And now I think you can find out the value of t quite comfortably, because this is nothing but a quadratic equation only. Yes, okay. You can solve this equation by splitting the middle term. You can solve this equation by quadratic formula, minus b plus minus under root b square minus 4ac upon 2a. Or you can also solve this equation by knowing the sum of the roots and product of the roots as well. Yes, there are multiple methods to solve this equation. Try to find out the roots. I think we can write down, if we do it by splitting the middle term, we can write down the equation like this. Yes, then taking t common from here, it will become t times of t minus 16. Taking 8 common from here, it will become t minus 16. And what we're gonna get is nothing but t minus 16 times t plus 8 equal to 0. So if the product of two things is equal to 0, we can definitely say that either this thing is going to be equal to 0, or this thing is going to be equal to 0. That means we can say that either t will be equal to 16 or t will be equal to minus 8. Now t is nothing but p times q. So what we get is nothing but the value of p times q. Therefore, p times q is either equal to 16 or minus 8. Yes, I think we guys are clear with this particular problem, kids. Have a look at this particular problem. P plus q was given to us, p to the power 4 plus q to the power 4 equal to 272 was given to us. The question was asking us to find out p times q. This is a JEE main problem. Nothing else we have used, but what we have used is a plus b to the whole power 2 along with quadratic equation. That's it. Nothing else is there in this problem. Any difficulty in order to solve this JEE main 2021 problem? No, I hope we guys are quite comfortable with this. Let's move ahead and learn a few more important things. Here we go. Now, if I ask you what is the expansion of x plus 1 by x to the whole power 2? Can you do it by using a plus b ka whole square? Since we know that a plus b ka whole square is nothing but equal to a square plus b square plus 2ab, if we apply it over here, we can see that in place of a, x is written, and in place of b, 1 by x is written. So the moment we apply this identity over here, we can get x square plus 1 by x square plus 2 times of x times 1 by x. Yes or no? X and x got cancelled. So what we are having is nothing but this particular thing, x square plus 1 by x square plus 2. Easy? Okay, I want you guys to hold this equation with you for a few seconds. Hold this equation with you for a few seconds. Okay, let's take this up, x minus 1 by x to the whole power 2. Let's apply a minus b ka whole square. Sir, why are we doing that? You'll come to know. A minus b ka whole square, we know it is equal to a square plus b square minus 2ab. Okay, this will become what? This will become x square plus 1 by x square minus 2 times of x times 1 by x. Similarly, we can write down this equation like this. Let me call this equation as equation number 2. Now these two equations which I have written, equation 1 and equation 2, are a very, very, very important thing, especially in JEE questions. I'll tell you why these are very important questions. If you remember, I told you in the beginning that if you want to solve these kind of problems, these a bit tough looking problems, we will be using these identities. So in order to solve this question, we need few concepts like these two equations. Like these two equations. Wait, where is it? Here it is. Okay, so what we have got so far is x plus 1 by x ka whole square can be written as x square plus 1 by x square plus 2. This was from 1. And this is what we have got from the second one, that this thing can be written as this. Yep, everyone? Okay. Now, if we see in these two equations, this portion is same, isn't it? This one. Same portions. So, if you want to write down the value of x square plus 1 by x square, let's say, in terms of either this or this, we can use this equations. What am I trying to tell you over here is, let's say from these two equations, I want to write down the value of x square plus 1 by x square. Then from equation 1, I'll take this 2 onto the left hand side. I can write down this expression as x plus 1 by x ka whole square minus 2. And if I use this equation, I can write down the value of x square plus 1 by x square by taking this minus 2 onto the left hand side like this. Yes or no, everyone? So these two things are very, 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 very important, guys. These two things are very, 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 very important. I'll tell you the importance of these two things in JEE questions as well. And I'll tell you how JEE frames up the questions. So I hope we guys are fine till here, that x square plus 1 by x square can be rewritten as either this or this. Two ways of writing down x square plus 1 by x square. Okay. Let's make a note over here because a lot of guys, take it in a wrong way. So let me write down that note. That x plus 1 by x square, a lot of guys say that this thing is equal to x square plus 1 by x square. No. How can these two things be equal? If we apply a plus b ka whole square, we can see over here that plus 2 also comes over here, isn't it? So these two things are definitely not equal. A lot of guys do what? They take this power 2 and give it to x, as well as they take this power 2 and give to this x as well. And they say, sir, these two things should be equal. No, definitely no. Right? Okay, these two things are not equal. Number 2, if you want to apply such kind of a thing, so such kind of thing happens only in this kind of problem, in this kind of things. Let's say I'm having a times of b and the whole power m is given to me. Then I can write down this thing as a to the power m times b to the power m. But only in the case when multiplication between the two terms is written, a and b. Here not multiplication but addition is written. So you cannot apply this thing over here obviously, right? Okay, so let me come back to this agenda, this one. That x square plus 1 by x square can be rewritten in two ways. Either in terms of x plus 1 by x, like this. X plus 1 by x ke terms mein we can write down this particular expression like this. And we can also write down this expression in terms of x minus 1 by x, and that like this. So we must remember these two things. Either we will be writing down this particular thing like this depending upon the question's demand, or we will be writing down this particular thing like this depending upon the question. Okay, so this is very important thing that we should remember this. Alright, I hope we guys are clear with these two things. Anyone is having any doubt till here? It's a very simple application of a plus b to the whole power 2. Yes or no, all of you guys? Okay, so now we are equipped with all the things desired to solve this particular example. So let me write down the example. Let's say I want to solve this particular equation. Solve for x is the question. What I need to find out is the values of x which satisfy this particular equation, or the roots of this particular equation, because those values of x which satisfy this equation is nothing but known as roots of this equation. Or we can say we need to find out the solutions, that is the possible values of x in order to get this equation solved. Yes, okay, solutions, roots, or the values of x satisfying the equation, all are same things. Now let's see how we're gonna solve this problem. Now I am telling you one very important rule. Whenever you see x to the power 2, 1 by x to the power 2, x to the power 1, 1 by x to the power 1, and a constant term. How many terms? 5 terms. X to the power 2, 1 by x to the power 2, x to the power 1, 1 by x to the power 1, and constant terms. Whenever you see these 5 terms, the thing that I am teaching you over here should pop up in your mind. Okay, whenever we see these 5 terms, x to the power 2, 1 by x to the power 2, x to the power 1, 1 by x to the power 1, constant. As of now, I just want you to memorize this thing, that whenever these 5 terms will come into the picture, you will be using this particular thing. As we move ahead into our victory batch, I'll tell you why this was possible, and in the cases where this particular thing is not possible. Okay, where we cannot solve problems like this, and where we can solve problems, by this method, and where we cannot solve problems like by this method. Okay, as of now I'm telling you what, whenever you see x to the power 2, 1 by x to the power 2, x to the power 1, and 1 by x to the power 1, and a constant term, 5 terms, you will apply the thing that I am teaching you over here. Okay, sir, I remembered it. Now, how to apply this thing is a major question. So let's have a look at this. If you see this question, can you write down the question like this? Yes, sir, we can definitely write it down. No issues. Okay. Now we know that there is one term. Okay, sorry. There is one term, this one. We can write down the question like this. There is one term. Okay, wait a minute. I have written it wrongly. Sorry. Yep. Yeah. I can rewrite my question like this. Yes. No change I have done. X square plus 1 by x square was given to me. I have put these two things in a bracket. Nothing else I have done. Okay. We can write down the question like this. Now we know that we can write down x square plus 1 by x square in two ways. We can write down x square plus 1 by x square in two ways. One is x plus 1 by x to the whole power 2 minus 2, and another was x minus 1 by x to the whole power 2 plus 2. Yes, recall this. We have learnt this thing on the last page only. Yes, okay. Now, out of these two, which we should apply? Which particular thing we should apply? Let's see. Over here in the question, x plus 1 by x is already going. Yes or no? X plus 1 by x is already going. So we need to write down this particular thing in terms of x plus 1 by x only. So we need to put this thing as this. Why? Because in the problem, x plus 1 by x is already going. So we need to put this thing also in terms of x plus 1 by x only, and that is this particular thing. Sir, what's the purpose of putting this thing in terms of x plus 1 by x? I'll tell you. You might have solved quadratic problems like this. Let's take a few examples. If I give you a problem like this, x square minus 5x plus 6 is equal to 0. Can you guys find out the roots of this particular equation? Roots are x equal to 2 and x equal to 3. Yes, splitting the middle term, quadratic formula, anything you can apply and you can get the answer. I said okay. If I give you a problem like this, what you can do? You can say, sir, how to solve this problem? We can see that x square thing is coming multiple times in the problem. Yes or no? If you rewrite this problem like this, you can observe it in a fairly easy way. That x square is coming in the problem multiple times. Yes. So what we do is we put x square equal to t. And the problem becomes t square minus 5t plus 6 equal to 0. And from here we know that what is the value of t possible? T is equal to 2 or t is equal to 3 is possible. Yes or no? Now 2 and 3 are not the roots of this equation because we were solving for t, we were solving for x, not for t. T is what we have assumed. So we will put once again what is the value of t, x square, that is in terms of x. And now if you solve this problem, you can write down x equal to plus minus root 2. And from here you can write down x equal to plus minus root 3. Yes or no? So the solution of these equations are going to be 4. What are they? X equal to plus minus root 2 and plus minus root 3. That is plus root 2, minus root 2, plus root 3 and minus root 3. The learning over here is whenever you see the same term getting repeated in a problem, you assume that as t and then you can make it into a quadratic, and the quadratic you know how to solve. Again, I'm telling here we were solving for x, not for t. That's why the moment we have got the value of t, we have converted it into x first. So t was nothing but x square. So from there, we're going to get the value of x. Okay. If a problem is given to you like this, let's say. If a problem is given to you like this, let's say. X plus 2 to the power 2 minus 5 times of x plus 2 plus 6 is equal to 0. Again, you can see over here what? Sir, x plus 2 is coming multiple times. X plus 2 is coming multiple times. So what we do is put x plus 2 is equal to 2t. And the problem becomes t square minus 5t plus 6 is equal to 0. Yes or no, kids? And from here, you can write down the solution t is equal to 2 or t is equal to 3. But these are values of t, not of x. You have to ultimately solve for x. So t is nothing but x plus 2, putting it over here. What we get is nothing but the value of x only, that is x equal to 0 or x equal to 1. Yes or no, kids? So these are my two required solutions from this particular question. Again, have a look at this over here. If the same thing is coming again and again, we first take that thing as t, then we make a quadratic, and we know how to solve a quadratic. We get the values of t. The moment we get the values of t, we can again put what was given to us in the original question, that is t ke jagah par what was given, x plus 2 was given, simply putting it and getting the values of x, and the question is solved. Right, everyone? So here also, you can see that this is x square plus 1 by x square. This is x plus 1 by x. So these are two different things. But can we convert this thing x square plus 1 by x square in terms of x plus 1 by x, so that if Same thing, x plus 1 by x comes again and again in the problem. We can assume it as t and then we can make it a quadratic, and we know how to solve a quadratic, and the question can be solved in a relatively easier way. So that is what the purpose of putting either this thing as either this or this. Now in this particular question, x plus 1 by x is already coming over here. So we're gonna put this expression in terms of x plus 1 by x only. That is this particular form we will be using. So using it in order to solve the problem over here, we can write down this thing as x plus 1 by x ka whole square minus 2. Putting this thing simply over here, minus 5 times of x plus 1 by x plus 6 is equal to 0. Yep, okay. Rearranging this equation for a few, simplifying this equation, we can see that there are two constant terms coming. So combining them together, our equation becomes something like this. Minus 2 plus 6. That is plus 4. Okay, this is minus 5 times of this thing. This minus 5 is not alone. This minus 5 is getting multiplied both with x and with 1 by x as well. So this is not a constant term, minus 5. This minus 5 has been multiplied with x as well as 1 by x. So this minus 5 is not a constant thing. It has been multiplied with x and 1 by x. So constants are what? This one and this one. So we have clubbed these two terms and written over here as 4. I hope we guys are fine with this. Okay, moving ahead. Now we can see over here that the same thing is coming again and again. Look, x plus 1 by x, x plus 1 by x. So the moment we see that same thing is coming again and again, what we're going to do? We're going to put it as t, and then it will form a quadratic, and we know how to solve a quadratic. Yes or no, everyone? So what we can do over here is we can put x plus 1 by x as a t, and the equation becomes what? The equation becomes t square minus 5t plus 4 equal to 0. The equation becomes t square minus 5t plus 4 equal to 0. And we know how to solve this quadratic equation. We have multiple ways to do it. So we can either use splitting the middle term, or we can use quadratic formula to get the roots of this particular quadratic equation, kids. So we can write down this equation as this. And from here we can get two roots, that is t is equal to 1 or t is equal to 4. No issues, everyone? I think all of you guys are absolutely clear with this particular thing. Now we were not solving for t in the original question. We were solving for what? We were solving for x, isn't it? So we can put again, what was t? T is nothing but x plus 1 by x. So simply putting it over here, x plus 1 by x equal to 1 or x plus 1 by x equal to 4. Yes or no, everyone? Now, how do we solve these equations? I think we can simply take the LCM. Cross multiplying it, we're going to get something like this. Taking this x onto the left hand side, we're going to get something like this. And we know how to find out the roots of this quadratic equation. That quadratic formula, you know, just apply it and get the roots. Similarly over here, taking the LCM, we're going to get this. Then this, cross multiplying this x with the 4, and then taking this 4x onto the left hand side. And we know how to solve these two equations. Let's solve these two equations for the value of x. I hope you know that if a quadratic equation like this is given to you, how to find out the roots of this quadratic equation? Roots are, what are the roots? Roots are x equal to minus b plus minus under root b square minus 4ac over 2a. So let's apply it and write down the roots, kids. So the roots are going to be what? 1 plus minus under root 1 minus 4 into 1 over 2. That is, the roots are what? Sir, the roots are imaginary. Whenever the roots are imaginary, we're going to say no real roots. Okay? No real roots. Or we can say non-real roots. Non-real roots. Okay? And over here, if you see, what will be the roots, beta? The roots will be 4 plus minus under root 16 minus 4 into 1 upon 2. That is, under root 12 will come over here, right? 2 plus minus under root 12 can be written as 2 root 3. So it will become 2 plus minus root 3. So this equation only have this root, these two roots. These are not real roots. These are not real roots. So ultimately what we are getting the value of x as 2 plus minus root 3. That means this equation will be having only two roots, because from this particular portion no real root was coming. So we are not going to take that, because imaginary roots or non-real roots we take only in the chapter what? Complex numbers. So this equation is not having any real roots, so we are not going to take the values of x from here. But this equation is giving us the real values, that is 2 plus root 3 and 2 minus root 3. So ultimately this equation will be having only two roots, that is 2 plus root 3 and 2 minus root 3 kids. I hope you guys are clear with this. Let's have a look at this example once again. X square plus 1 by x square, and this equation was given to us. Have a look at these five terms. X square is there, 1 by x square is there, x is there, 1 by x is there, and a constant term is there. If these five terms are there in a problem, we can apply what I have taught you, that is x square plus 1 by x square can be put in these two different forms. Now, the moment we separate this x square plus 1 by x square like this, we can put this x square plus 1 by x square in two ways, first or second, either this or this. But depending upon the question, we're going to do that. Depending upon the question means what? Since the question is already having x plus 1 by x in it, we're going to take this form up and simply putting it in place of this. So that is what we have done, taking this as it is. Okay, moving ahead. Combining the constant terms together, we got the equation like this. Now x plus 1 by x was coming multiple times, so let's assume x plus 1 by x as a t. So the equation becomes quadratic, that is t square minus 5t plus 4 equal to 0. Then we know how to solve a quadratic equation. So the two roots are going to be t is equal to 1 and t is equal to 4. Remember, we are not solving for the value of t, rather we are solving for the values of x. So t was what? X plus 1 by x, putting it over here and here as well. Then taking the LCM and forming a quadratic in x. The moment we form a quadratic in x, we know quadratic formula to find out the roots of any quadratic equation. Simply applying it, we got non-real roots over here, so we are not going to take them up. And here we have got these two real roots, that's why these two real values of x are going to be my solution of this particular problem. I hope we guys are clear with what we have learned so far, everyone. Anyone is having any confusion? If the problem is having x minus 1 by x over here, let's say, if the problem is having x minus 1 by x over here, we're gonna put this expression in terms of x minus 1 by x. How? Like this. I hope we guys are clear with this. Anyone is having any difficulty? No difficulty? Is it good enough to move on to the next concept? Yes, all of you guys? Or you want me to give you one more problem? Let's do one more problem, kids. Let's take this problem up. For the practice example. Let's say an equation like this is given to me. Okay, let's say an equation like this is given to me and the question is telling me to solve for x. Now have a look at these five things. X square is there, 1 by x square is there, x is there, 1 by x is there, and constant term is there. Whenever these five things are there, your mind should give you a signal that follow what Arvind sir has said. Segregating this x square and 1 by x square terms and then simply writing the equation as it is. We know what? We know one thing, and what's that? We know that x square plus 1 by x square can be written in two ways. Either x plus 1 by x to the whole power 2 minus 2, or x minus 1 by x to the whole power 2 plus 2. Yes? Now in this question, which form we should use? We can rewrite this thing as x minus 1 by x ka whole square plus 2. Why? Because x minus 1 by x is already there in the problem. Yes or no, everyone? Yes, sir. Okay, moving ahead. We can combine the constant terms over here and we can rewrite this equation like this. Yes, okay, plus 10. Yep, equal to 0. Yes or no? Anyone is having any difficulty in this part? So do let me know. Yep. No? Okay. Moving ahead, we can put x minus 1 by x as a t. So the equation becomes t square minus 5t plus 10 is equal to 0. Let's solve this equation, but we can see over here one thing, that the discriminant of this particular equation is negative. Whenever discriminant is negative, we get non-real values. So from here, discriminant is negative of this quadratic. Discriminant is negative, less than 0. So this quadratic is not going to give me real values of t. No real values of t. No real values of t I'm gonna get. And if t ka I'm getting no real values, so t is what? It is equal to x minus 1 by x only. So if this is not real, obviously these two things are not going to be real. So from here we can say no real value of x. No real value of x. That means no solution for the particular question as per this equation. Let me tell you this thing again. Since this equation is having discriminant negative less than 0, how much is it? 25 minus 4 times 1 in times 10. That is minus 15 is the discriminant of this equation, which is negative. So the roots are going to be non-real roots. That means t ka non-real values I'm gonna get. So if this t is a non-real value, obviously this x is also going to be non-real in nature. And if it is non-real, we are going to say that this equation has no solution. Yes, just like we have done over here. Because this even though here t was coming out to be real, hai na? Here let me tell you, wait a minute. Yep, here t was real. Kahan gaya? Wait. Where are you? Where are you? Concepts, where are you? Where are you? Right? I hope you understood this, that the values of t are non-real in nature. So the value of x is also going to be non-real in nature. And we talk about non-real values only in the chapter what? Complex numbers. Except that in every chapter we say no solution if there is no real solution. Yeah. So the question will be having no real solution. Now, moving ahead and building some more concepts, kids. If you remember, I have given you the problem like this. The first problem that I have given you was this. Recall. What's recall? Problem that we have solved earlier. Recall. We solved earlier. We solved this equation earlier. Yes, we solved this equation earlier. Okay. Yep. If I say that can this equation be rewritten like this? Can this equation be rewritten like this? Yes, sir. What we have done? Minus 5 we have multiplied with this x, minus 5x. Minus 5 we have multiplied this with this 1 by x, we're going to get minus 5 by x. Yes. So both of these problems are same only. Okay. I said okay. Fine. So now onwards, if I give you a problem like this to solve, what you first going to do? You're going to take the common thing from these two terms. Let's say over here minus 5 is common in these two terms. So let's take this minus 5 common up first. And then the problem becomes like this, and you know how to solve problem like this. Yes, comfortable? Okay. If I take LCM, will the LCM is going to be x square or not? the moment you take the LCM, the problem becomes like this. Yes or no? We have done nothing but just taken the LCM. Yes? Okay. Now the moment you have taken the LCM, we can cross multiply as well. This x square we can multiply with 0. 0 times x square becomes what? 0. So don't you think that the same problem can also be rewritten like this? X to the power 4 wala term is over here. Then writing down x ki power 3 wala term. Then writing x square wala term. Then writing down x wala term. And then writing down the constant term like this. So let me call this thing as equation 3. Don't you think that equation 1, equation 2 and equation 3, all of them are same? Equation 1, 2 and 3 all are same. So if the equations are same, don't you think that their method of solving also needs to be same? If the equations are same only, then their method of solving should also be same, isn't it? Yes or no, everyone? Yes. So you have to feel this in the question. Let's say I give you a problem like this, you can definitely feel that this thing can be written in two ways, either in terms of x plus 1 by x or x minus 1 by x. But here in the problem, x plus 1 by x is already going, so you're going to put this thing as x plus 1 by x to the whole power 2 minus 2, and then you can simply solve the question assuming x plus 1 by x as a t, and the problem will be solved. Okay, if I give you a problem like this, then from the term x and 1 by x wala term, you're going to take the common thing. So minus 5 is common. The problem will simply become like this, and you know how to solve this problem. Moving ahead, if a problem is given to you like this, it's very important. Understand this. If the equation is having x to the power 4, any equation having the highest power of x as 4 is called as biquadratic equation. What do we call any equation having x to the power 4? Biquadratic equation. So this is a biquadratic in x. Biquadratic. Why do we call this as biquadratic? We are calling it as biquadratic because the maximum power of x present in this equation is 4. Now, if a biquadratic equation is given to you, that is having the maximum power of variable as 4, like this. This equation is having a term x to the power 4, also having x to the power 3, also having x to the power 2, also having x to the power 1, and also having a constant term. Again, look, 5 terms. X to the power 4, x to the power 3, x to the power 2, x to the power 1, and a constant term. These 5 terms, whenever you see in a question, these 5 terms, the thing that should come in your mind is divide this equation by x square. Whenever you see such kind of a thing, that whenever these 5 terms are there in an equation, what you have to do is divide. What? Divide by x square. Both the sides. Over here, if you do division by x square, so 0 upon x square will become x square only. But on the left hand side, if you do division by x square, it will become like this. And this same thing can be rewritten like this. Yes or no? And this thing you know how to solve because you can convert this thing like this, and you know how to solve this particular equation. So learn, understand. I can give you a problem like this, or I can give you a problem like this, or I can give you a problem like this as well. The problems are all same. You just need to understand. If I give you an equation having x to the power 4, x to the power 3, x to the power 2, x to the power 1 and constant term, you should feel that I have to divide by x square so that the problem will be converted like this. And then this same problem can be rewritten like this, and this same problem can be rewritten like this, and I know how to solve this problem. Are we guys clear, everyone? Yes, all these problems are same only, and their method of solving is also same. Sir, how can you be so sure that if a biquadratic equation is given to you and if terms like this are coming, x to the power 4, x to the power 3, x to the power 2, x to the power 1 and a constant term is coming, and how you can be sure then that we have to solve like this? So beta, there can be other cases as well, but this is the most important one. Majority of the biquadratic problems will be solved like this. But the biquadratic equation must have x to the power 4 term in it, x to the power 3 term in it, x to the power 2 term in it, x to the power 1 term in it, and a constant term. All these 5 terms has to be there. Then there are 90% chances that the problem will be solved like this only. Sir, what about 10% chances? That we will see once we learn calculus in class 12th. So whatever question that will be asked to you, majority of the questions, if a biquadratic equation is given to you and 5 terms are there, will be solved like this only, that divide by x square, the equation will be reduced to this, then the same equation can be rewritten like this, then this equation can be rewritten like this, and we know how to solve this equation. Are we guys clear? There are multiple cases, other cases as well, but that will come once you learn calculus, and you haven't learned calculus in class 11th, you will learn that in class 12th. Are we guys clear? Any doubt so far? Are we guys clear? Shall we move ahead? Okay, now in this thinking process, JEE takes you one step ahead. JEE takes you one step ahead. JEE does what? Let me tell you. JEE does what? JEE does this. This means what, sir? I'll tell you. E to the power 4t minus 5 times of e to the power 3t plus 6 times of e to the power 2t minus 5 times of e to the power t plus 1 equal to 0. And they say solve for x, solve for t, because t is the variable over here. Now JEE does this. JEE asks questions like this. Now the kids are worried. Sir, you haven't taught us this. How can this be solved? But this can be solved. I have told you, whenever same thing comes again and again and again in the problem, you do what? You simply put that thing as a variable, let's say x, t, y, or since t is already going in the problem. So what we can do? We can see here that e to the power t is coming again and again and again in the problem. Because I hope you know that a to the power this can be rewritten as a to the power m times n. Yes or no? You know this? Can you now observe that this thing can be written as e to the power t to the whole power 4 minus 5 into e to the power t to the whole power 3. Then this thing can be written as e to the power t to the whole power 2 minus 5 into e to the power t plus 1. Can you now observe that e to the power t is coming again and again and again in the problem? If yes, you can put this e to the power t as some variable, let's say y or x or whatever. So the problem becomes y to the power 4 minus 5 y to the power 3 plus 6 y to the power 2 minus 5 y plus 1 is equal to 0. And now y to the power 4, y to the power 3, y to the power 2, y to the power 1 and a constant term. All the 5 terms are coming. So the thing should pop up in your mind that I need to divide by y square, because over here the variable is y. Divide by y square. So the moment you divide this equation by y square, on the right hand side 0 upon y square will become 0 only, but on the left hand side the equation becomes something like this. Now this same equation can be rewritten as what, kids? The same equation can be rewritten as, okay, this will be 1 by y square over here. And this will 0 by y square. 0 by y square is 0 only. Okay. So rewriting this equation y square, and then this 1 by y square, then this minus 5y, then this minus 5 by y plus 6 is equal to 0. Okay. Then the same equation, look, y and 1 by y is, things can be taken common. So taking these things common, my equation becomes something like this. Y square plus 1 by y square minus 5y minus 5y minus y by, what was there? Minus 5 by y. 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 Yes, minus y by 5. And then what was there? 6, okay, is equal to 0. And now we can write down this thing by taking minus 5 common. Oh, sorry, this is 5 by y. Like this. And now you know how to solve this problem. How to solve this problem? We know that we can write down this thing as y plus 1 by y ka whole square minus 2, and then we have already solved this equation earlier as well. So we can directly write down the values of y since we have solved this problem already. There it was x, so simply we can put y in place of that. So what we were getting over here is, क्या मिल रहा था बेटा हमको? Let me see the solution of this. This was the equation. Which one? This one. Wait. This was the equation? इसी में अगर if you put x के जगह पर y, in place of x if you put y, so the equation becomes same, yes or no? So the solution has to be what? Y equal to 2 plus minus root 3, yes or no? So simply taking it over there. है ना? Since we have already solved it, so why do we need to solve it? It's important to learn. The board is working so slow, I don't know why. Yeah. Okay. So as solved earlier, what we can do is we can say that y equal to 2 plus minus root 3 is coming. Yes, sir. But we were not solving for y, kids, in the original problem. We were solving for t. So simply put, what is the value of y now? That is e to the power t. So putting it over here, e to the power t is equal to 2 plus root 3, or e to the power t is equal to 2 minus root 3. Now, if you have learnt logarithm, so you know that whenever in mathematics, if power is variable, we use logarithm both the sides. So over here, e is a constant and t is a variable. E, I hope you know, logarithms ke andar we use this Napier's constant. Yep. So the t is variable, so we will take log both the sides, or ln rather. So if we use ln both the sides, it will become ln e to the power t is equal to ln of 2 plus root 3. So this will become, by using the property of logarithm, this will become t is equal to ln 2 plus root 3 only, and this will become t is equal to ln 2 minus root 3. So how many values of t I am getting, kids? I am getting 2 values of t. One is this and one is this. If you are not able to use the properties of logarithm, that's fine. We can have a look at logarithms in detail. But if you are fine till here, that is also fine as of now. You can simply write e to the power t is equal to 2 plus root 3 as of now, if you are not aware of logarithms. And you can leave it till here. In the next lecture on relations and functions, we're going to learn logarithms. So this thing is going to be very, very, very easy for you as well. Understood? Everyone, all of you guys, if JEE gives you problem like this, don't be worried. Don't be worried, because they will definitely do that. Because you are a student of Arvind Sudhar sir, and you know how to solve this deadly looking problems as well. Because if you are following this lecture right from the first minute, you can easily grasp each and everything that I'm sharing over here. Yes or no, kids? Any difficulty in whatever we have learnt so far? Is your brain able to, capture all the things that I'm saying? The things are relatively easier. You just need to follow this pattern. A lot of guys feel about mathematics is that, sir, if we memorize the process, is it possible to solve the new questions which will be coming in our way in JEE? Yes, definitely. Because look, if whenever if let's say you are traveling in some terrain, okay, and you don't know the paths, the more you travel there, don't you think that you will be able to remember the paths? Let's say you are going from your home to a market nearby. If you haven't been there earlier, everything is new for you. But if you have been there multiple times, don't you know that all the things coming in your way, you might be aware that if I go right, I'll reach there. If I go left, I'll reach there. If I go straight, I'll reach there. Yes or no? So that is what I'm telling you. If you remember a few things in mathematics, that is definitely going to help you guys. So our agenda is what? If we are here into the examination, then we must remember the rule of we must remember the rules of clearing this examination. And the number one rule is, do remember the way initially I am telling you. The more problems you're gonna do, you will be able to understand, and no problem will look tough to you guys if you following the algorithm that I'm telling you. So look, if I give you this question directly, you'll be like, "Arey sir, what have you given? What have you given to us?" But now I think if you see such kind of question, you will be able to understand this is quite easy, yeah. Yes or no, everyone? Yes. So this may look a bit difficult, but it isn't anymore. I hope you guys are clear with this, all of you guys. Okay. So this application is what I wanted to teach you guys, at least for the two identities, a plus b to the whole power 2 and a minus b to the whole power 2 as well. I hope you guys are clear with whatever we have learned so far. Moving to next identities. Next identities. Okay. So the first identity now we're going to take up is a plus b plus c to the whole power 2. Now, this you will have to remember. You have no other choice. How we going to get? Obviously, we're going to get this thing by multiplying these two things up. If you multiply these two things, then this a will be multiplied with all three of them. 3 terms we're going to get. Then this b will also get multiplied with this. And then similarly, this c will also be multiplied with all three of this. And then you see what you're going to get is nothing but the formula that I'm sharing over here with you guys. And that is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, so we must remember this, even though most of you guys will already be familiar with this particular thing. So you must remember this, number one. Number two is this, a minus b, or let me write it like this, a square plus b square plus c square minus ab minus bc minus ca. Look, this thing and that thing are different. Yes, okay. This thing is equal to half times of a minus b to the whole power 2 plus b minus c to the whole power 2 plus c minus a to the whole power 2. Sir, how can we see this? But don't you know a minus b ka whole square? It is a square plus b square minus 2ab. Put it. Don't you know b minus c ka whole square? B square plus c square minus 2b into c. Put it. C minus a ka whole square, you know, c square plus a square minus 2a into c. Yeah. Put it. Cancel out the terms. You will see that both of the things are coming equal. So you must remember this as well. Number two. Number three. A plus b plus c times this thing. A square plus b square plus c square minus ab minus bc minus ca. A plus b plus c times this thing is equal to a cube plus b cube plus c cube minus 3abc. You must remember all these three things. I think majority of the guys already know about this first one, but you must remember these two things as well. You must remember these two things as well. Now, I'm going to share with you when do we need to apply these identities. Look. Whenever three terms are given having square in it, each and every term is squared, like a square, b square, c square, and having plus signs in between them. So either you can use this equation or this identity, or you can use this identity, or this or this. Okay? What am I telling you? It will be clear if it is not yet. Okay? Don't worry. But whenever three terms having square in it are given, either this identity will be used or this identity will be used. But if three terms are having cubes in it. So this identity has to be used. This identity has to be used because there are a cube, b cube, c cube, 3 terms in it. So whenever 3 terms having cubes are given to you, you will be clicking in your mind that you have to use this. Okay, the same thing can also be if we put this thing, which was over here, as this thing. Let's say we put this thing over here. The identity is going to remain same, yes or no, kids? So you must remember that as well. Now, taking you ahead. If I say example, let's do a few examples. Example. If I say that a plus b plus c is equal to 4 and ab plus bc plus ca is equal to 2, find a square plus b square plus c square. If this kind of question is given to you. Now, your mind should click that these terms, this one, and this one comes in which formula. So these 3 terms, a plus b plus c, ab plus bc plus ca, and a square plus b square plus c square comes in this formula. Yes or no, kids? Why? Because if you take 2 common from these terms, if you take 2 common from these terms, you can simply write down the same thing like this. Yes or no? So if out of these 3 terms, a plus b plus c, a square plus b square plus c square, and ab plus bc plus ca, if any 2 things are given to you, and the question is needing the third thing from you, you can definitely use this identity. As you can see over here, a plus b plus c is equal to 4 given to you. That means this one thing is given to you. AB plus BC plus CA, that means this thing is also given to you, and the question is needing this third thing, a square plus b square plus c square. If out of these 3, 1, 2 and 3, if any 2 things are given to you, you can find out the third by using this equation. I hope you guys are clear with this. So let me put the values over here. So this will become 4 square. This is what we need to find out, and then 2 times of 2 we can simply put it. So a square plus b square plus c square becomes what? It becomes 16 minus 4, that is equal to 12. So what is the value of a square plus b square plus c square? That is nothing but equal to 12. I hope you guys are clear with this. Anyone is having any sort of confusion in this? No? Alright, moving ahead. Talking about the second one. The second one is a bit crucial. A square plus b square plus c square minus ab minus bc minus ca. Let's take a problem based on this, or concept related to this identity. Related to a square plus b square plus c square minus ab minus bc minus ca. This was equal to what? This is equal to half times of a minus b ka whole square plus b minus c ka whole square plus c minus a ka whole square. Yes or no, kids? Okay, let's learn concepts related to this. In mathematics, you must remember, whenever I am dealing with real numbers, if x square plus y square is equal to 0 given to you, x and y are real numbers. If x and y are real numbers. If x and y are real numbers, x square plus y square is given equal to 0, then x and y both has to be equal to 0. If you have learned complex number, then the things would have been different, because if you have learned complex number, then in complex number this thing can be written as x plus iy times x minus iy. So there it is not necessary that x and y should be both equal to 0. But if x and y are given to you real numbers, then this x square plus y square equal to 0 gives you that both x and y should be equal to 0 only. This is a very, very, very important thing. Number 1. Similarly, if it is given to you x square plus y square plus z square is equal to 0, then if x, y, z are real, so the same thing is going to happen. Why? Because the square can never be negative of a real number, at least. Whether the real number is positive, negative or 0, the square of any real number can never be negative. Yes or no? Yes, sir. So in this case also, x and y and z should all be equal to 0 only, provided x, y and z are real. Okay. Now giving you a very important thing. If let's say it is given to me that a square plus b square plus c square minus ab minus bc minus ca is equal to 0 given to me. If considering one case that this thing is equal to 0 given to you, then you can definitely say that the right hand side should also be equal to 0, because this thing is always equal to this since it is an identity. So you can say that this thing is also equal to 0. Yes or no, kids? Yes, sir. If this thing is given to me equal to 0, then definitely this thing will also be equal to 0 since these two things are always equal. An identity. I said okay. Now if you multiply this half or 2 with that 0, cross multiply, the 2 times 0 will become 0. That means this thing is going to give you what? A minus b ka whole square plus b minus c ka whole square plus c minus a ka whole square equal to 0 only. Now see, if I am saying you that a, b and c are real, if a, b and c are real, if a, b and c are real, then a minus b is also going to be real. If a, b and c are real numbers, so a minus b is going to be real, b minus c is going to be real, c minus a is also going to be real. Yes or no, everyone? Yes, sir. If a, b and c are real, then definitely this will follow this particular thing. Yes or no? And in that case, we can definitely say that a minus b, b minus c and c minus a, which are written in place of x, y and z, should also be equal to 0 only. So this thing has to be there. Yes or no, kids? Do let me know. Yes or no? Tell me. Come on, kids. Yes. So if this is the thing, then let's see. A minus b has to be equal to 0, means a and b should be equal. Okay, b minus c also needs to be equal to 0, means b and c should also be equal, and c minus a should also be equal to 0, means c should also be equal to a. That means this thing has to follow or not. So what am I trying to tell you is, if a square plus b square plus c square minus ab minus bc minus ca is equal to 0 given to you, then this thing can come equal to 0 only in the case when a, b and c are all equal. A lot of guys feel that this thing should also be 0, but this is not necessary. If a, b and c are equal, let's say a, b and c are 3, 3, 3. So if you put over here, put 3 square plus 3 square plus 3 square minus 3 into 3 minus 3 into 3 minus 3 into 3. Don't you think still it is coming equal to 0 only? A lot of guys see कि sir ये 0 होना चाहिए. But I said over here x, y and z should be equal to 0. Yes. Similarly over here also a minus b, b minus c and c minus a should be equal to 0. It may not mean that a, b and c should be 0. A minus b should be equal to 0 means a and b should be equal. B minus c should be 0 means b and c should be equal. C minus a equal to 0 means c and a should be equal. But a, b and c may or may not be equal to 0. A lot of guys also put equal to 0. This equal to 0 is not a true thing over here. A, B and C should be ultimately equal, because if A, B and C are equal, then this thing is also 0 ka square plus 0 ka square plus 0 ka square. A, B and C are equal. So let me write down this important note over here. What's that note? If A, B and C are equal, then a square plus b square plus c square minus ab minus bc minus ca is equal to 0. If a, b and c are all equal, then a square plus b square plus c square minus ab minus bc minus ca is equal to 0 only. Or if this thing is happening, then we can say that a, b and c should be equal. Okay, number 1. If you can recall that we have learned this identity, identity 3. A square plus b square plus c square minus ab minus bc minus ca is equal to a cube plus b cube plus c cube minus 3abc. Remember? Now see, if this thing is equal to 0 given to me, let's say, then the entire product is going to be 0, because 0 into anything will be equal to 0 only. Yes or no? Yes, sir. Okay. So if I want to find out the cases, if a cube plus b cube plus c cube minus 3abc, that is the right hand side, is given to me equal to 0, then if this thing is 0, then this thing is also 0, and the product of two things is 0 when the first thing is 0 or second is 0, then either a plus b plus c is 0, because 0 into anything will become 0, or this thing should be equal to 0. This thing should be equal to 0 means a, b and c should be equal, yes or no? Because this thing was equal to 0 when a, b and c were all equal, yes or no? Because if a, b and c are all equal, then this may be non-negative, this may be non-zero. If a, b and c are all equal, this may or may not be equal to 0, but this thing will always be equal to 0 if a, b and c are all equal. So 0 into anything will become 0 only. That means the right hand side has to be equal to 0 only. Whenever a, b and c are equal, this thing has to be equal to 0 only. Also, if this thing is equal to 0, let's say a, b and c are not equal, and a plus b plus c is given to equal to 0 to you. So if this is 0, then 0 into anything has to be equal to 0 only, means this thing will also be equal to 0. So this thing will be equal to 0 in two cases. Either when a plus b plus c is 0, or a, b and c are all equal. This is equal to 0 when a, b and c are all equal to 0. Yes, everyone clear? So you must remember this as well as this. The two important takeaways of the identities, kids. Now let's do a few examples based on what we have learned so far. Example. Let's say I want to find condition between P, Q and R. Let's say P, Q and R. If P square plus 4Q square plus 9R square plus minus 2PQ minus 2PQ minus 6QR minus 3PR equal to 0. Find condition between P, Q and R if this kind of a thing is given to equal to 0 to you. Now, the moment you see three square terms, two things should come into your mind. What are those two things? As I told you, either this or this. First one or second one. Yes or no, kids? Let me take you there once again. Either this identity or this identity. Because this is having three square terms in it, this also having three square terms in it, yes or no? So which one we should apply in the problem that I have just given you, this or this? Try to think. First one or second one, which one we should apply over here? Try to think, everyone. Which particular identity we should apply? Try to think, kids, come on. Since these are squares, so A can be plus P or minus P, because ultimately A square will become P square only. Even if A is P or minus P, A square will become P square only. I said okay. If B I take as 2Q or minus 2Q, ultimately B square will become 4Q square only. If I take C as either plus minus 3R, ultimately C square will become 9R square only. Now, out of this plus minus P, plus minus 2Q, plus minus 3R, we should take plus P or minus P. We should take plus 2Q or minus 2Q. We should take plus 3R or minus 3R, will depend upon this remaining portion. So, based on that, try to think. Come on, try to think, come on. Since we know that A square plus B square plus C square minus AB minus BC minus CA. If we want to form this kind of a thing, so obviously we can see that minus 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 is coming over here. That means A, B and C should be taken as positive, with positive signs only, or all with negative signs. Look, if I take A, B and C, I can take either A as P, B as 2Q and C as 3R, or I can take A as minus P, B as minus 2Q, and C as minus 3R. Don't you think that both the equations are going to satisfy? So, sorry, with these values also, this equation is going to give me this only. And with these values of A, B, and C also, this equation is going to give me this only. Feel it? So I think if this thing is equal to 0 given to us, we can definitely feel what? That A, B, and C has to be equal. If this is the scenario, then P should be equal to 2Q is equal to 3R. And if this is the scenario, then minus P should be equal to minus 2Q is equal to minus 3R. If you cut these minuses, you will definitely feel that both are same things only, because this can only be rewritten like this. But if you take A as P, let's say, and B as minus 2Q, if you take A as P and B as minus 2Q, do you think that this equation in that case will give you this only? No, because here it will become plus 2Q. The moment you take A as P and B as minus 2Q. Yes or no? Feel it? So we cannot take A as P and P as minus 2Q, B as minus 2Q, right? Because these signs will not get satisfied. That is what I am telling you. These are three squares given to you. Now this is P square and I am comparing it with A square, let's say. So A can be plus minus P, because ultimately if we square this, we're going to get P square only. This is 4Q square, and if we compare it with B square, we can take B as plus minus 2Q. If we square it, obviously B square will be equal to 4Q square only in both the cases. If we compare this 9R square with this C square, we can say that C can be plus minus 3R, because ultimately square in both the cases is going to give you 9R square only. Yes or no? But whether we should take plus sign of this or minus sign of this, plus sign or minus sign of this, plus sign or minus sign of this will depend upon these remaining terms. So if we take A as plus P, B as plus 2Q, and C as plus 3R, this equation is going to get satisfied. So that's why I have taken A, B, and C like this. Similarly, if I take A as minus P, B as minus 2Q, C as minus 3, again like this, this equation is going to get satisfied, because ultimately this, putting these terms over here, will give this equation as this only. Yes or no? And I know that whenever A square plus B square plus C square minus AB minus BC minus CA is equal to 0, then A, B, and C has to be equal. So putting these values of A, B, and C in this equation gives me this equation only. That means A, B, and C should be equal, means P is equal to 2Q is equal to 3R has to be there. Are you able to understand this? I'm giving you next example so that you can understand this thing in a better way. Let me give you that as well. Example. Let's say I give you an equation like this. Okay. Find relation between P, Q, and R. Now feel it, kids. Now feel it. By looking at these three squares, the thing will come into your mind that A can be taken as plus minus B, B can be taken as plus minus 2Q, C can be taken as plus minus 3R. But out of these two, which should be the value of A? Out of these two, which should be the value of B? Out of these two, which should be the value of C? Depends upon these terms. Now, C, I want to make plus 2PQ over here. So ultimately the equation is what? A square plus B square plus C square minus AB minus BC minus CA. If this thing is equal to 0 given to you, then A and B and C all has to be equal. A, B, and C all has to be equal. Yes or no? Okay. Now try to think what should be the values of A, B, and C. Out of these two, what should be the value of A? Out of this, what should be the value of B? What should be the value of C? Try to think. If I take A as, let's say, P, B as minus 2Q, and C as plus 3R, can you feel that this putting these values over here will give you the exact same equation only? Let me write down equal to 0 over here. Yes or no? Feel it? So don't you think that these should be the values of A? That is, therefore, A, B, C should be equal, means P should be equal to minus 2Q should be equal to 3R. That is what I was telling you. You will have to think a bit over here and then you will be fluent with it. But you will have to think a bit. Some brain will definitely get applied over here. Right? I hope you guys are clear with this. Anyone is having any confusion, please do let me know. Fine? Okay. Moving ahead. Talking about the third identity, find a cube plus b cube plus c cube minus 3abc if a plus b plus c is equal to 2 given to you and ab plus bc plus ca is equal to 4 given to you. Okay, I hope the question is clear to you. We need to find out a cube plus b cube plus c cube plus minus 3abc. So we know the formula in which this particular term comes, that this thing is equal to a plus b plus c times a square plus b square plus c square minus ab minus bc minus ca, kids. Now a plus b plus c I am having, sir. I said okay, this is equal to 2. Okay, AB plus BC plus CA is also given to me. I said, okay, let me rearrange it. So I can write down the same thing like this. Taking minus common, it will become AB plus BC plus CA. So this thing is given to me equal to 4. So I said no issues. So the entire thing will become something like this. 2 times of A square plus B square plus C square minus 4. Now I don't know the value of A square plus B square plus C square. Can I get that somehow? Can I get that value somehow, kids? A square plus B square plus C square. Because the moment I get the value of A square plus B square plus C square, my entire question is solved. Yes or no? So we know that A plus B plus C ka whole square is what? It is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Yes or no? Okay. By using this equation, can we somehow calculate the value of A square plus B square plus C square, kids? Try to feel it and do let me know the answer. Yes, definitely we can. Because A plus B plus C ka whole square will become 2 to the power 2. Okay. A square plus B square plus C square is what we want. I said fine. Okay. And then 2 times of this value is what we already know. Putting it over here. So from here we can definitely see that A square plus B square plus C square is going to be 4 minus 8. That is equal to minus 4. Yes or no? Putting this value minus 4 over here, what we gonna get is nothing but 2 times of minus 8, that is equal to minus 16. And our question is solved. I hope you guys are clear with this. Any confusion of whatsoever kind, do let me know, kids. I think it is a very, very, very easy thing to understand. Yes. So this very simple application of identities we need to remember, because these identities can come anytime, anywhere. So we must know how to solve these identities and we must remember how to solve such kind of things. All right. Okay, moving ahead, talking about inequalities now, kids. Inequalities, that is our agenda number 2. We are done with the basic identities. If the kids are wondering, sir, we're gonna cover the entire inequalities over here, so definitely no, beta. We're gonna look at logarithmic functions later in the chapter relations and functions. We're gonna have a look at modulus later, that is the lecture number 2 itself, and there only we will be discussing their inequalities as well. So here, the level of inequalities that we're going to take will be very basic in nature. Why? Because this is my first lecture in the Victory Batch and I don't want to extend this lecture beyond a few hours. That is what my intent is. So definitely we're going to cover all those portions as well. We're going to cover greatest integer function in depth, including inequalities and equalities. We're going to cover fractional part function with inequalities and equalities both. We're going to cover modulus as well, logarithms as well with equalities and inequalities, but not here in this particular lecture, but in the next, that is lecture number 2, which is on relations and functions. I hope you guys are clear with this. Okay, moving ahead, inequalities. Inequalities do have these kind of symbols. I hope you guys are already aware. Okay, if I give you this particular statement, can you read it mathematically? A is greater than B. Yes or no? A is greater than B. Yes, this is how we read this. Okay. Number 2, if I give you something like this, A is this, so how do we read it? A is greater than or equal to B, or equal to B. Third thing, if I give you something like this, A is less than or this, so we can say A is less than or equal to B. And if I give you something like this, so we can read it how? We can read it A is less than B. Yes or no? Anyone is having any confusion in this? No confusion seems to me so far. Okay. Okay. Based on this, do let me know, if I give you something like this, is this statement true or false? Is this statement true or false? This is true. Now a lot of guys feel that this is false, but let me tell you guys, this statement is a true statement. Why? Because we read it like this: 5 is greater than or equal to 5. 5 is greater than or equal to 5. 5 is greater than or equal to 5. Now, whenever or is there in mathematics, we do have a choice. Remember your class 10th board examinations, one question was given over here, then or was written, then another question was written. Have you solved both of the questions, or you solved only one and the entire marks were given to you? Only one, right? So if any one thing is also happening, we say that's fine. The thing is going to be true only. Yeah? Or you're going to get full marks? Yes or no? So here 5 is definitely not greater than 5. But 5 is definitely equal to 5. Yes or no? So out of these two things, greater than or equal to, one thing is happening, right? That's why this statement has to be true. I hope you guys are clear with this. Any confusion in this? If out of these two, greater than or equal to, any one thing is also happening, then this has to be correct. Why? Because or is coming in between. Or is coming in between. Okay? Chalo. Let me tell you, let's take this problem up. This is true or false? 7 is definitely greater than 5, though 7 is not equal to 5. So out of those two things, one thing is happening. So this thing has to be true. Yes? Okay. If I give you something like this, this is true or false, kids? 5 is greater than or equal to 7. 5 is definitely not greater than 7. But we know that 5 is definitely not equal to 7 as well. So this is true or false? False. So we must know this at least. Clarity on this part? Okay, number 1. Number 2. I want to tell you one concept in mathematics. Okay, let me ask you one question. X by x and 1. Are these two things equal? True or false? True or false? Tell me. X by x and 1. Are these two things equal or not? True. If this thing is equal, then say true. If thing is not equal, then say false. Okay. This is false. X by x is a different thing and 1 is a different thing. What people do usually is they take this x with this and they say, sir, this is also 1 and this is also 1. So the two things has to be equal. These two things are not always equal. These two things are not always equal. Why? Why? Because x by x is equal to 1 everywhere. Everywhere except x equal to 0. Except x equal to 0. What happens at x equal to 0? At x equal to 0, x by x becomes 0 upon 0. And in mathematics, you might have learnt that division by 0 is undefined. In mathematics, denominator can never be equal to 0. So that becomes undefined. So this expression becomes undefined at x equal to 0. Whereas if you look at this, If I say put x equal to 1 into this, you will say, sir, there is no x. I said, okay, there is no x. Then ultimately this will be 1 only, whether I put x equal to 1. This will remain 1 only. If I put x equal to 0, this will also remain 1 only because there is no x in it. Yes or no? I say put x equal to 3 into this, this will still remain 1 only because there is no x. If I say put x equal to -1 into this will still remain 1 only. Yes or no? Yes or no, everyone? Whether I put x equal to 0 into this will remain 1 only because there is no x. Yes, so this is always equal to 1. This is always equal to 1. Always equal to 1. That means that is for all real values of x. From -infinity to infinity, if you do, this will always give you the value 1 only. If you take any value of x from -infinity to +infinity and you put it inside this, so there is no x, this expression is going to give you a value equal to 1 only. But this is not going to give you 1 when you put x equal to 0 into this. If here you put x equal to 0, this is going to give you 1. If here you put x equal to 0, this will become undefined. Now, a lot of guys say, sir, I have cancelled out this x and x. But you can cancel out only when that thing is non-zero. When that thing is non-zero, then only you can take it. You can cancel it. Just say 14 by 2 ko you can definitely write down 7. Why? Because when you are cancelling it, 2 is a non-zero number. So no issues. Are you getting my point? Because 2 is a non-zero number. That's why you can cancel it. But if it is a 0, then you cannot cancel it. Then you cannot cancel it. Just say, let's say I give you x minus 3 ka whole square over x minus 3. You cannot write it down as x minus 3. But if you want to write it down as x minus 3, then you should write that x is not equal to 3. Since x is not equal to 3, because in mathematics denominator can never be equal to 0, then you can cut it and you can say that this thing has now become x minus 3, but only in the case when x is not equal to 3. So I can say what? X by x equal to 1. X by x equal to 1 when x is not equal to 0. X बस 0 नहीं होना चाहिए, उसके अलावा everywhere x जो x upon x जो है that will be 1. Otherwise this thing should be written that x is not equal to 0. Here x not equal to 0 was not written, that's why this was false. Now this is true. Because if x is not equal to, if x is 0, then this thing is undefined. X upon x, this is not equal to 1 in that case. So you have removed that case, that whenever x is not equal to 0, then only this thing will be equal to 1. If x is equal to 0, then obviously this thing is getting undefined. That's why these two things will not be equal. So x is not equal to 0 whenever this is there. So x by x ko you can write down as 1. I hope you guys are getting the point. Yes? Okay. Now, most of the times what happens, let's say a problem like this is given to you. And kid does what? They say, they have written it like this, sir. And they write it like this. This will become wrong. This will become wrong. Why this will become wrong? Because if you are cutting it down, then you will have to definitely write down that x is not equal to 2. Because if x is equal to 2, then the denominator here is 0. Which can never be the scenario, because in mathematics, denominator can never be equal to 0. So if you want to write down this thing correctly, you can write it down like this. You need to write down this thing as well, that x should not be equal to 2. I hope we guys are clear with this. Okay, moving ahead, talking more about inequalities. Here we go into the world of inequalities, kids. Let's say I have been given a is greater than b. This is given to me that a is greater than b. A is something which is greater than b. It is given to me. If I add same number or subtract same number from both the sides of inequality, the sign of inequality is not going to change. It doesn't matter whether c is positive or negative. It does not matter whether c is positive or negative or 0. Positive or negative or 0. Because let's say I'm having 10 kgs on this side and 2 kgs on this side. So this side is going to definitely weigh more. If I say that I have added 15 kilos to both the sides, look, I'm adding same number to both the sides. I'm adding same quantity to both the sides. Still, this quantity is going to weigh more. Yes or no? 25 and this 17. Okay. If I take 1 kilo out of both of them, still which one is going to weigh more? So whether this C is positive or negative, it does not matter. Whether it is 0 also, then also it does not matter. So if I'm removing or if I'm subtracting same quantity from both the sides of the inequality, just minus C, sign of inequality will remain same. If I'm adding same quantity plus C on both the sides of inequality, sign of inequality will remain same. Whereas if I'm multiplying a number, the thing changes. If C is positive, then sign of inequality remains same. C is positive. But if C is negative, then the sign of inequality changes. Why? Let me tell you an example. Like 5 is definitely greater than 2. If I multiply both the sides by 2, this will become 10. Let's multiply both the sides by 3. 3 is a positive number. Okay, so this will become 15. 5 times 3 and this 2 times 3. Same number se multiply kar raha hu both sides. I am multiplying the sides of inequality by same number. So this will become 7. Still, which one is more? This one. If I, let's say, multiply both the sides by 10, so this will become 50, this will become 20. Still, which side is weighing more? The side which was earlier weighing more. So if I am multiplying both the sides by a positive number, then sign of inequality remains same. Look, it hasn't changed. But if I am multiplying a negative number in both the sides, C, if C is negative, then sign of inequality changes. Let's have an example of this as well. Let's say 5 is greater than 2 given to me. I know this is true. If I multiply both the sides by minus 3, it will become minus 15 and it will become minus 6. Now, which one is greater? Minus 6 definitely. Look, sign of inequality changed. So whenever I am multiplying a negative number in both the sides of inequality, the sign of inequality changes. Is it clear, beta? Okay. Moving ahead. Talking about the next thing. The same thing happens with the division as well. If C is a positive number, the sign of inequality will remain same. If C is a negative number, sign of inequality changes. You can feel it. You can take any example and you will be able to understand. So these are few things which every one of you must know. Okay, like let's say if this is given to me, x plus 1 times x plus 1 is greater than 2x minus 1. Let's say this is given to me. Okay, and I want to know that what is the relation between these two terms now. Same number, say I have multiplied both the sides, minus 2. The sign of inequality is going to change or not, or it will remain same. The sign of inequality gonna change. Why? Because I have multiplied same negative number on both the sides of the inequality. So I can be sure that the sign of inequality will change. But if I multiply here with minus 2, there with minus 3, I don't know. If I'm multiplying both the sides by, by different numbers, so that I cannot say. I'm saying that if we multiply both the sides of inequality by negative number, same negative number, the sign of inequality is going to change. If I multiply both the sides of the inequality by positive number on both the sides like this, so the sign of inequality is going to remain same. That means this thing has to be bigger as earlier, because I have multiplied both the sides by 2, which is a positive number. Okay. So if this thing was given to us, we can definitely deduce this result. I hope you guys are getting this. Similarly, in the case of division as well. Okay. Let's say I want to subtract both the sides by 4. The equation demanded me to, in order to solve the equation, it was demanded that I need to subtract 4. So sign of inequality will remain same or it will change. Here it doesn't matter whether you add or subtract. If you are adding same number or subtracting same number, the sign of inequality will remain same only as told to you on this particular slide. Clear, kids? Okay. Now, moving ahead. Let me give you few more things over here. Yeah. Let's say A greater than B is given to you. This is given. And you need to square. Okay, you need to square. A square will be greater than equal to B square if A and B are both positive. If you are sure that A and B are both positive, then definitely you can square. The sign of inequality is going to remain same. Just say if we take the example, here it will become 25 upon squaring, here it will become 4. So definitely sign of inequality will remain same. So upon squaring, sign of inequality will remain same if both sides positive numbers are written. But if negative numbers are written, A and B are negative numbers, then A and B are both negative, so sign of inequality changes. Let's have an example. -5 and let's say -10. If you square, this will become 25, this will become 100, yes or no? Look, sign of inequality changed or not? This happens whenever A and B are both negative. Okay? Okay. Okay, now if I'm saying that if 1 is negative, now understand that possibility, that if out of A and B 1 is negative, from this particular thing, what can you say? Which one should be positive and which one should be negative? Look, both positive we have taken, both negative we have taken. Now considering the case, 1 is positive and 1 is negative. Can it ever happen that B is positive and A is negative? Can a negative number be greater than a positive number? No. So this can never happen, that B is positive and A is negative. So considering the case that A is positive and B is negative, you don't even need to square. No need to square when out of A and B, one is positive, one is negative. Understood my point? Because look, if I know that this is the thing, this is true, why? Because I don't need to square. Why? Because here if you square, this will become 25, this will become 4. You will say the sign of inequality will remain same. But if you do like this is also true. If you square, look, now which one is greater? This. So if one side is positive and one side is negative, anything can happen. You cannot be sure, yes or no, that sign of inequality is going to change or it will remain same. So no need to square when out of A and B, one is positive and one is negative. Otherwise, you will get wrong answer. Because let's say here, if you square, the sign of inequality will remain same. Here, if you do square, you will see that the sign of inequality will change. So if one side is positive and one side is negative, sometimes the sign of inequality remains same, sometimes the sign of inequality reversed. So you are not sure what will happen. So don't directly square in an inequality before seeing whether the two sides are positive, whether the two sides are negative. You must see this. Now what happens? A lot of kids does what? Let's say I give you an inequality like this. What they do is they simply square it. Now tell me kids, you are aware whether this side is positive or negative. If you are aware that these sides are positive, then the sign of inequality will remain same. But if you are not sure that the two sides are positive or not, then if these two sides are negative, then sign of inequality has to be reversed. And if one side is positive and one side is negative, you cannot even square. So while squaring in an inequality, you should be sure. You should be sure what? Whether the two sides, whether this is positive or not, whether this is positive or not. If both the terms are positive, then only square. If both the terms, then sign of inequality will remain same. But if both the terms are negative, then if you are squaring, the sign of inequality has to reverse. But if one side is positive and one side is negative, you cannot even square. And look over here, you can never be sure whether this x minus 1 is positive or not, because x is a variable. You don't know about the variable, whether the variable is positive or negative. So x minus 1 can be anything. It can be positive or negative. Similarly to x minus 1, it's having a term which is variable. So you cannot be sure whether this is positive or negative. So you cannot square. A lot of people do squaring directly. This will be wrong, beta. This will be wrong. Okay? Chalo. Okay, moving ahead, talking about few other things. And let me write down one note. While squaring, be careful in an inequality. While squaring, be careful in an inequality. एक तो number 1, in an inequality. Okay, number 1. Number 2 also I would like to make a point over here. Upon squaring, solutions might increase. Solutions might increase. What is the meaning of this? Solutions might increase. Let's learn it. Let's say I have given you a question like this. In normal mathematics also, let's say I have given you an equation like this. What will be the value of x? You will say, sir, x equal to 4. Right? Let's say one student comes and square over here. So for him, the equation becomes like this. Now, if he will solve it now, don't you think that this will become x square minus 6x plus 9 is equal to 1? And from here, the kid can say that this is a quadratic equation. So 2 solutions will be coming, sir. X equal to 2 and x equal to 4. Have a look at this. So look, it was not necessary to square over here to solve this equation. But the student squared it. And because he squared, he got extra roots, extra solutions. Yes or no? So upon squaring, the solutions might increase. So you should be careful about that. Square is a good weapon. But upon squaring, most of the times what will happen? The roots will get increased, like over here. Not just in the case of equality, but in the case of inequality as well. Let's say I want to solve this equation. And if you solve it normally, it will say that x should be greater than 4. But if a student comes and square it, and he says, sir, this is a positive number, so this should also be a positive number because 1 se bada hoga, tabhi to bada hoga. He said, he used this logic and he squared. The moment he squared, he will get something like this. Hai na? X square, or how can he or she solve it? I hope you have learnt it. And there are multiple ways. Either you can expand it, x minus 3 a minus b ka whole square you can do. Then you can bring this 1 square onto the left hand side. And or you can also do this, that directly you can take this up, then a plus b into a minus b, because this is now a plus a square minus b square. So you can do something like this. So this will become something like this only. Now the kid will see, if the kid sees the answer is x belonging to minus infinity, say 2 union 4 to infinity. Yes or no? If you have learnt a bit. If you haven't, then fine. But if you have learnt a bit, then one student will be getting this answer and the another student who have squared it will be getting this as an answer. Now let me tell you that this answer is definitely wrong. Here also this is wrong and here also this is wrong. Because upon squaring, what happens? You get multiple more solutions which are not even there. The answer here was only 4 to infinity, but the student who has squared is also getting minus infinity to 2 as the answer. So upon squaring, you should be careful. You should be careful कि भाई कहाँ square कर सकता हूँ, कहाँ square नहीं कर सकता हूँ, because whenever you do square, you get more solutions. You get more solutions. So be careful with the squaring. I'll talk more about this in the next lecture, but these are the few things where kids make mistake. That's why I'm keeping these, I'm giving you these logics. More about this, I will talk in the next lecture, that is under relations and functions. Okay? Okay. Number 2. Let me give you one more note. Try avoiding cross multiplication in an inequality. In an inequality. Inequality, a lot of students does what? Let me tell you. Let's say I have given you this example. 1 upon x minus 3 is greater than 4. Solve for x. Let's say I have given you. A lot of kids does what? They do it like this. They say, ki, sir, 1 over x minus 3 greater than 4 can be rewritten as this. Cross multiplied. This is wrong. This is wrong. This is what? This is wrong. You cannot write it wrong. This is wrong. Why? Now, in order to write down this thing, what have you done? Let's feel it. In order to write down this thing, what have you done is, you have taken this up and you have multiplied both the sides by x minus 3. Let's multiply both the sides by x minus 3. You're gonna get this. Now, are you sure whether x minus 3 is positive or negative? A lot of guys will say, sir, this thing is greater than 4, so definitely 4 is a positive number, so this thing has to be positive. But you are thinking too much. You are thinking too much. I'm just asking you, don't think too much whether this should be positive or negative or what. I'm not talking about that. I'm just saying simply, if I come in the class and give you and ask a thing, whether x minus 3 is positive or negative, so you will say, sir, we cannot say. Why? Because x can be anything. X can be plus 2, minus 2, plus 100, minus 100, anything. If you take x as minus 100, this thing is negative. If you take x as 100, this is positive. So this thing can be positive, negative or anything because x is a variable in itself. Yes or no? So you are not sure whether x minus 3 is positive or negative. So if I ask you to judge whether x minus 3 is positive or negative, don't judge it from here. Simply take this expression and see whether this is positive or negative. Sir, this can be anything. This can be positive as well as negative. Now, if this can be positive as well as negative, what will you do? Because we know if it is positive, sign of inequality will remain same. If it is negative, the sign of inequality has to change. Now, what should I take this? Whether I should take it as positive or I should take it as negative. Now, a lot of guys will say, sir, bring cases. If x is greater than 3, this is positive. So, for x greater than 3, we can keep the sign of inequality same. And for x lesser than 3, we can change the sign of inequality. I said that is fine, but why to make so many cases? We should avoid making cases as much as possible, otherwise the problem will become a bit complex. So rather we should do what? We should avoid doing cross multiply. Okay sir, we won't do cross multiplication because cross multiply is nothing but this thing only, multiplying the same thing on both the sides. Because from there only you were saying that this equation will become like this. Look. Yes, this will become 1 and this will become that. So cross multiplying is nothing but another way of looking at multiplying same thing to both the sides of inequality only. And we know that in an inequality, if we multiply same positive number in both the sides, sign of inequality remains same. But if we multiply same negative number in both the sides of inequality, sign of inequality changes. So there is an issue. So what should we do? Rather, if you want to solve this kind of problem, we should not cross multiply. Rather we should take this 4 onto the left hand side. And now we should take LCM. I hope you know how to take LCM. So this will become something like this, and you can now solve it comfortably because you know how to solve inequalities like this. If you don't know, I'll tell you in this session itself. I hope you guys are clear. We should try avoiding cross multiplication in an inequality because most of the times we can get the wrong answer. Because we are not sure. Because if we are learning, if I am telling you don't do this, then you should definitely not do that. Because if you will do that, obviously the answer is going to be wrong in most of the cases, right? So try avoiding cross multiplication. Instead of doing cross multiplication, what you can do, you can bring this 4 onto the left hand side, take the LCM, and now you are familiar how to solve this problem because this can be rewritten as minus 4x plus 13 over x minus 3, and I hope you might be knowing. If you are not knowing, you will definitely know in this session only. But this is a very easy problem to solve for now. Yes? Okay, moving ahead. So never do cross multiplication in inequality. Try avoiding as much as you can. If you can bring you can take this to this side and this to this side quite comfortably, no issue in that. But don't do cross multiplication as much as possible. Okay, understood this part? All right. Now, if I ask you this thing, okay, now it's very easy to tell that whether for what values of x this expression is greater than 0, and for what value of x this expression is less than 0. Yes or no? It's very easy. If you put any value greater than 3 over here, the expression will give you a positive value. Any value greater than 3 put. Because ultimately from the variable you are subtracting 3. So in place of variable, if you put any value greater than 3, the thing is going to be positive or not? And if you put any value lesser than 3, the thing is going to be negative or not? Yes. So linear factors, this is a linear expression. Linear expression possesses a very beautiful property. And what's that? Linear expression possesses a very beautiful property, and that is what? That they changes their sign. Let's say if you put a value of x greater than 3, this expression is going to give you a positive value. And if you put a value less than 3, this expression is going to give you a negative value. So around 3, the sign of this expression changes. This happens for each and every linear expression. Just say, let's say I have taken this linear expression. So at x equal to 1 by 2, this thing gets equal to 0. Yes or no? If you put any value greater than 1 by 2, this expression will be positive. If you put any value of x lesser than 1 by 2, this expression is going to be negative. Similarly, let's say you have taken this linear expression. If you put x equal to 1 by 3, this expression is going to give you 0. If you put any value greater than x equal to 1 by 3, this expression is going to give you negative value. And if you put any value lesser than x equal to 1 by 3 in this, so what you're going to get? This expression is going to give you positive value. Yes or no? So linear expression do possess this very, very, very important property. What? At a certain value of x, its value becomes equal to 0. And apart from and below those values of x or ahead of those values of x, the sign of the inequality is opposite. The sign of those expression is positive. Just if you see 3 per the value of this expression is 0. If you put any value greater than 3 inside this these are the signs for, these are the values of x, and these are the signs for x minus 3. So if you put any value of x greater than 3 over here, the expression is going to be positive. That is, x minus 3 is going to be positive. That's why I have written positive. And if you put any value of x lesser than 3 over here, the expression is going to be negative. Any value, if you put any value of x lesser than 3, that means out of these values, if you put any value over here, the expression is going to give you negative value. Yes or no? And if you put any value of x greater than 3, here the expression is going to give you positive value. Yes or no? Similarly over here, if you put x equal to 1 by 2, the expression is going to give you 0. If you put any value of x greater than 1 by 2 over here, the expression is going to give you what? Positive value. And if you put any value of x lesser than 1 by 2 over here in place of x, you're going to get a negative value for this expression. Yes or no? Okay, let's have a look at this. If you put x equal to 1 by 3, this expression will be equal to 0. But if you put any value of x greater than 1 by 3, any value of x greater than 1 by 3 over here, this entire expression is going to be what? Negative. And if you put any value of x lesser than 1 by 3 in place of this, the entire expression is going to be what? Negative. Yes or no? This happens for each and every linear expression, kids. At one place it will be positive. At one place it will be positive, then if one side it is positive, another side will be negative. Here also, if one side is positive, another side is negative, middle one 0. Here also middle one, if you put x equal to 1 by 2 over here, it will become 0. If you put any value lesser than 1 by 2, this expression will be negative. And if you put any value greater than 1 by 2 over here, this expression is going to be positive. Yes, this happens for each and every linear expression. Linear means the power of x, maximum power of x has to be 1. This happens for each and every linear expression. This doesn't happen for a quadratic function. This happens only for linear expressions. This happens only for linear expressions. This happens only for linear expressions, that on one side the expression is going to be positive, another side it is going to be negative. If this side it is positive, this side it is going to be negative. If this side it is positive, another side it has to be negative. Right? Understood, everyone? Yes? Any difficulty in this? All right, moving ahead. Now, let's say I give you a problem like this. Example, x minus 2 should be greater than 4, solve for x. Solve for x. Okay, I said fine. I need to find out those possible values of x which if I put over here, this inequality is satisfied. The meaning of the question is what? Put those values of x over here which satisfies this inequality. That means if you put those values over here, the inequality gets satisfied. So I said okay. Now my agenda is to form only x over here. How can I form only x over here? I can form x over here if I do add to both the sides of the inequality. If I add a same number or add or subtract same number on both the sides of the inequality, the sign of inequality remains same. So here the sign of inequality is going to remain same, and it is giving me that put values of x greater than 6, and that you can directly also think, if this number is greater than 6, so 6 minus 2 will be greater than 4 only, yes or no? So the answer should be this, right? Easier to understand? Okay. If I give you a problem like this, x minus 2, and this should be greater than x by 2 minus 1. Variable on both the sides, then also you don't need to worry. Or you can do what? You can take the x wala terms on one side, and you can take constant terms on another side. Solve for x. Okay, these are quite relatively very easier problems. So I'm explaining them directly. No need to worry. Okay. Okay. You can take this side to this side, this side to this side, because that is exactly same as doing. Let's say I want to take this 4, this minus 2 on this side, it will become plus 2, yes or no? So doing this thing, or saying x minus 2 less than 4 means taking this 4 onto the right hand side, they are both same things only. Plus minus you can take like this. If it is minus 2 over here, you can take it like this. It will become plus 2. Similarly over here, let's say minus 2 is written, you can take it like this, plus 2, it will become onto the right hand side. Plus x by 2 is there, if you take it, it will become minus x by 2. No issues in that. But you cannot cross multiply. That's a very important thing. Okay. Alright, so we can rewrite this equation like this. X by 2 should be greater than 1. Now, are you sure whether 2 is positive or negative? Yes sir, we are sure. So if you multiply both the sides by 2 now, because we know that 2 is a positive number, so sign of inequality has to remain same. Yes or no? Have a look at this. So we know that 2 is a positive number, and if you multiply this, the sign of inequality is going to remain same only. That's why we have multiplied it. If we are not sure whether 2 is positive or negative, we cannot do multiply. Right? Are you getting my point? So if you are sure the two side, the number that you are multiplying on both the sides of inequality, if it is positive, then only multiply, otherwise do not multiply. I hope you guys are clear with this. Okay. Now, if let's say these kind of things are given to me, x minus 2 times of x minus 3 is greater than 0, solve for x. Now look, I know that if linear factors are given to me, then we can quite comfortably say that linear expression do changes the sign about a certain value of x. Just say let's take, we take this linear expression. So at x equal to 2, this becomes 0. At values of x greater than 2, it will become positive. At values of x lesser than 2, it will become negative. Similarly, at values of x greater than 3, this will be positive. At value of x equal to 3, it will become equal to 0. And at value of x less than 3, it will become what? Negative. Right? We know about linear expression. But the question is telling me what? It is saying me find out those values of x which we put over here if the inequality is satisfied. Okay. So in order to solve these inequalities, what we can see, observe over here, we can see for values of x greater than 2, this is also positive and this is also positive, yes or no? So for values of x greater than 2, this is also positive and this is also positive. Okay. For values of x greater than 3, this is positive. Okay. Whenever the x is less than 2, this is also negative and this is also negative, yes or no? If you put any value of x less than 2 here, this will be negative. This will also be negative, yes or no? Okay. And if you put value of x greater than 3, this is also positive and this is also positive. But if you can feel it like this, that this will become negative. Let me tell you this thing. How do I get these signs and what exactly are these signs of? This is a very important thing to understand. A lot of guys do not understand this, though it is a very easy thing, but let me write it down for you guys. Okay. Yeah. First plot this thing becomes equal to 0 at what value of x? So at x equal to 2, it becomes 0. This thing becomes equal to 0 at x equal to 3. So mark down these points. Now, let me write it down over here, sign of x minus 2, and let me write down sign of x minus 3 over here. The two linear factors which are written in multiplied form over here. Okay. I have to write down the sign of those two things. Now, I have taken a number line. The number line goes from minus infinity to infinity. Okay, and I'm cutting down the number line at these 2 points. Why at these 2 points? Because this thing is getting equal to 0 at x equal to 2 and this thing is getting equal to 0 at x equal to 3. That's why I'm cutting down the number line at these 2 points. So 3 portions I'm having. One is 3 to infinity, another one 2 to 3 and another one minus infinity to 2. Okay, chalo. Moving ahead. Now, if you see, if you put any number greater than 3 inside this, don't you think that this is going to be a positive number only? Let me write down. If you put any number greater than 3 over here, 4, 5, 6, 7, 8, 9, any number, don't you think it is going to be positive? Okay. Putting any number between 2 to 3 inside this, 2.5 let's say, don't you think it is going to be positive? 2.6, 2.7, anything. Here, if you put any number between 2 to 3, it is going to be positive or negative? Sir, it is going to be negative. Yes or no? Any value, 2.1, 2.2, 2.3, 2.4, anything. Okay. Putting any value less than 2 inside this is going to be negative. This is also going to be negative. You can take any value, 0, 1, minus 1, minus 2, minus 3 and put it over here. It is going to give you a negative value. This is also going to give you a negative value. Yes or no? Now, if in this branch we see, this branch, this expression is also negative and this expression is also negative. These are values of x. These are values of x which I am considering. Okay. These are all values of x which I am considering. Okay. So if we take any value less than 2, then x minus 2 is also negative and x minus 3 is also negative. So in these values of x, if you see, this is also negative and this is also negative, means negative into negative will become what? Positive or not? So if you see sign of x minus 2 times x minus 3, so it will become minus into minus, that is equal to what? Plus. Yes or no, kids? Okay. If you look in this branch, so this will become plus times minus, that is equal to minus, that is negative. Okay, and if you look in this branch, it will become plus into plus because x minus 2 is also plus, positive, and x minus 3 is also positive, that it means it will become positive. In the question, what you wanted this expression to be positive, greater than 0, isn't it? In which of the following regions positive sign is coming? Here and here. Okay. Number 1. Number 2, C. Is x equal to 2 your answer? If you put x, these points, these individual points which you have earlier marked on the number line. Is x equal to 2 your answer? No. Because if x equal to 2 you put, this thing will become 0. So this will become 0 greater than 0. 0 greater than 0, this will become at x equal to 2 if you put. Is it a true thing or false thing? False. That's why x equal to 2 is not the answer. So marking open circle over there. And also putting x equal to 3, the thing will become same, which is also not true. That's why putting a open circle again over here. Now, these two regions were our answer. So let's write down these two regions. So it becomes what? It becomes minus infinity to 2 union 3 to infinity. At infinity and minus infinity, we always put what? Open bracket. And minus 2, sorry, 2 is not our answer. That's why open bracket. 3 is also not our answer. That's why open bracket on that as well. So this is the final answer. So with the help of this only, wavy curve method is derived. But I recommend this method because this is very, 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 very basic. And this is always going to give you the correct answer. Okay. If I ask you a problem like this, let's say x minus 2 times x minus 3, okay, plus, greater than 2. Solve for x. Now look, it is always very easier for me to say whether the product of linear factors is positive or not. Like in this problem, the product of linear factors is positive or not. It is very easier for me to say rather than कि the product of linear factors is greater than a certain value or is lesser than a certain value, like this. So what I do always is I try to make 0 over here, always, because it is always very easier for me to say whether the product of linear factors is positive or negative rather than saying कि यार the product has to be greater than 2, what should be the value of x, like that. Okay. So what I do is, I first multiply these two things, so it will become x square minus 5x plus 6 greater than 2. Now I make 0 over here, that means I take this 2 onto the left hand side, and I rewrite my question like this. So my problem becomes something like this. And now I'll factorize it once again, and I rewrite it like this. So again it is written as the product of linear factors. And the linear factors ka product is positive or negative, it is very easier for me to say. Are you getting my point? So now if you do the same process, first we're gonna put 1, then 4. Definitely these are not our answers. Why? Because over here equality is not given. If equality is given over here, then definitely they would have been our answer. I said okay. Now what we're gonna do is, we're gonna write down sine of x minus 1. Then here we're gonna write down sine of x minus 4. So over here you can see any value of x greater than 4, if you put over here, this is going to give you value positive. Any value of x greater than 4, if you put over here, this is going to give you a positive value. Then this positive 1 to 4, any number, let's take 2 and put over here x equal to 2, x equal to 2 put karte hain. Here also x equal to 2. So you will get these signs. So from here definitely you can say that if you want to find out sine of x minus 1 times x minus 4, so over here you can see minus into minus, which is nothing but positive. Okay, over here if you see, so it will become positive into negative, that is equal to negative. And over here if you do, it is nothing but positive times positive, that is equal to positive only. Yes. So what you wanted here, you wanted the expression to be positive. Positive means this region, and this region is your answer. So combine these two regions to get the final answer, and your final answer is what? Minus infinity to 1 union 4 to infinity. Yes, understood everyone? Yes, any difficulty? If I give you a problem like this, let's say, if I give you a problem here like this, let's say example, if I give you a problem like this, x minus 2 times x minus 3 is greater than or equal to 0, solve for x. So in that case, only one change will happen, that x equal to 2 and x equal to 3, that is these 2 points will also be our answers. Why? Because over here equal to 0 is written. So if you put x equal to 2 inside this, this will become 0, and the inequality will become 0 greater than or equal to 0. So that is a true thing. That's why x equal to 2, and that's why x equal to 3 will also be the answers. So the final answer in that case is going to be what, bete? The final answer is going to be minus infinity to 2 union 3 to infinity. Okay. And if I ask you over here, let's say if I ask you over here, example, x minus 2 times x minus 3 is greater than or equal to 2, solve for x. Equality is written. Then the answer would have been what? The answer would have been minus infinity to 1. Infinity and minus infinity always we put open bracket. This thing. Understood everyone? Anyone is having any sort of difficulty in this, so feel free to ask. Okay. Now this method is nothing but the crux of wavy curve method only. This is the crux of wavy curve method. Okay. Because wavy curve method, if not applied properly, will give you wrong answers most of the time, but this method will never give you wrong answers. If you want me to explain wavy curve method in detail, that I'll definitely do, but in the next lecture, as told earlier, here we will be sticking with the basic examples only. Let's say I want to solve this inequality. So we have already seen how do we solve these inequalities. Do we cross multiply, everyone? No, we do not cross multiply. Rather, what do? We take this, we bring this 4 onto the left hand side, and then now taking the LCM, we can write down the expression like this. And this question becomes like this for us. Okay. And now you know how to solve this. How to solve this? What do we do? Since linear expressions are created. Okay, so making this linear thing equal to 0. So this will become how much? 5 by 4. Okay, so 5 by 4 will come over here, and 1 will come over here. Definitely in mathematics, denominator can never be 0. So x can never be equal to 1. That means you have to put x equal to 1 per open circle only always. Why? Because x can never be equal to 1. Because in the original question, you have to see that denominator can never be equal to 0. Yes, that's why x can never be equal to 1. So that will never be your solution. Number 2 is this x equal to 5 by 4 if you do. So the inequality is satisfied or not satisfied? Not satisfied, right? That's why an open circle over here as well. Now, using that same sign convention thing. So if you do, let's say sine of minus 4x plus 5, and here if you do sine of x minus 1 you do, so you can see that if you put any value greater than 5 by 4 into this expression is going to give you negative value. Yes, 5 by 4 means 1.2 something, so let's put 2, you will get an idea. And here if you do, you will get positive value. Okay, 1 to 5 by 4, so you can put 1.1, right? 1.1. 1.1 comes between 1 and 5 by 4 only, feel it. So 1.1 if you do, so this is going to be negative. Okay, let me see, positive, and this one is going to be positive only. All right, moving ahead. If you put any value less than 1, let's say 0, this is positive and this is negative. So if you see what? If you see sine of minus 4x plus 5 upon x minus 1, here positive over negative will come. That is, positive over negative is what? Negative. Here positive over positive will come. That is what? Positive. Here negative over positive will come. Negative over positive, that means negative will come. What you want is this expression to be greater than 0. Greater than 0 means you want it to be positive. Here is the positive thing. So the final answer is going to be what? 1 to 5 by 4. This is the final answer. Understood? Now, a lot of kids who have, understood the concepts of wavy curve method, they forget to make the coefficient of x positive. And they say that the answer is going to be minus infinity to 1 union 5 by 4 to infinity, right? This happens with a lot of kids because they forget to make the coefficient of x positive. And ultimately they get the wrong answer. But in this method, you will never get a wrong answer. Understood my point, everyone? Yes. There are few more things where you cannot apply or you will make mistakes in wavy curve method. Okay. So that I don't want. That's why I am sticking with the concepts that I have told you here so far. That try, if you are not fluent with, if you have become fluent with wavy curve method, you always get the correct answer by using that entire method, then you can follow it. But if you sometimes get the correct answer and sometimes get the wrong answer, try avoiding that method. Rather do the question by these signs, because these signs will always give you the correct answer. There is no scope of doing the question wrong if you follow these sign conventions. If you want me to explain that method, that also I'll do obviously in the next lecture. But you must learn this as well, because from here only wavy curve method has been derived. So we will take the remaining things in the next lecture. As told you earlier, logarithms completely we will take in sets, relations and functions only. So this we will take in next lecture only. The entire logarithms we're going to take there only. Modulus also we're going to cover in the modulus function itself, and equalities and inequalities we will be covering in the second lecture. Also greatest integer function, the entire function part, and also equalities and inequalities we will be learning in the next lecture only. And fractional part function also we will be learning in the next lecture only. Okay, and irrational inequalities also we will learn in the next lecture only, because I have felt that a lot of guys do have difficulties in irrational inequalities. Okay, so this is our first lecture and I wanted to keep it a bit short so that we guys are prepared that what exactly we will be covering. So in this lecture, I hope you might have learnt so many things, right? The basic identities portion, I am quite sure that you have learnt so many new things from this session, and now you are confident how to solve such kind of questions in a more comfortable way. So I would like to tell you one thing, that we're gonna end the session here only. Yep, So we're gonna end the session here only, and we will be covering all these things in the next lecture, so that we guys are all on the same page and we need the whatever we have learned in the 11th journey so far, and whatever we have left also, because है ना क्या होता है कि what happens, there might be a few chapters which are backlogs of yours, right? So definitely you need to cover those as well before going full-fledged into class 12. So definitely we're going to cover that portion as well. For today, that's it. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this JEE preparation. See you in the next one. Bye bye. Take care. Stay safe.